In previous sessions, we discussed about how we can use iOS XE devices in order to fetch out details from the device and in order to even deploy configurations on the device as well. In this particular class, I'm going to give you a glimpse of how I would say designing and maintainability and serviceability of the applications are basically taken care of. And then we are going to move ahead to take these particular things in consideration while fetching out or while creating our next Python scripts for advanced automations by using REST API, definitely. So there are like two aspects now that we're going to discuss about. One of which is designing maintainability, or you can say designing for maintainability of the application. And second, we're going to talk about designing for serviceability. Now, you probably might feel that this is quite often off the track, but whatever we're going to discuss in these two couple of sections today, these things can definitely be used in order to create your automation stuff. So it doesn't actually matter that what kind of front end thing that you're developing, because as we had as I had a word in our previous classes, that whenever you have a router there and that particular router is actually being configured, then you can either use restconf, or you can also use netconf, okay, or you can use probably Ansible, which we are going to discuss in a couple of further classes, or you can use various other methods. You can use, I would say, NetMiko, which is just for SSH and all, and certain other things. It can also be plain REST API. To use all of these things, there can be GUI applications and there can be code-based applications. And when you work with GUI application, one of a very popular application that we use is Postman, that is used in consideration of sending API calls by using REST API or RESTConf. Or you can use Python that can help you deploy configuration or fetch out configuration and all by using all the methods, okay, from the device and all. But how you can use or how you can like create a production project that will also take care of not just creating the very first things, be it a script or be it an API or so, but also how you can improve that, how you can utilize it in future projects as well. For that, maintainability and serviceability of the developed thing, not only application, but it can be a Python script as well or something else, needs to be focused on. So that's exactly what our motive is going to be for this particular training, sorry, for this particular class, that how things are looked up to when it comes to their service, when it comes to their maintenance of your development. So the maintainability of, you can say, a software, because this is the very first thing that we're going to discuss about, right? Yeah. So maintainability of any application or software or code is often thought about as a scale that actually tells you how difficult an application or a piece of code is to, and to understand uh, that you need to actually be familiar with its structure, and then you will be able to kind of understand the behavior of the code, or understand the or you can say maintain the code or repair the code if there are any bugs or so. And even you can optimize or enhance the code as well when you actually understand the structure of that. Now with long running applications, the cost of maintenance can often amount to half of like half or like more of the project related expenses, which is why it is important to make software as kind of maintainable as you can, okay, and in both design and implementation. So there are two types of functional and non or like requirements that you need to cater in order to make sure that the application is maintainable. One of which is called as functional requirement, and the other is called as non-functional requirement. Okay, these are a couple of categories that we often consider. So when designing a software, it is often very hard to evaluate kind of how the applications should be built and which design patterns should
If
actually
you
be used.
enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
When we talk about functional requirements, then you can say functional requirements specify what a software or what a code in question should do. Okay, like they describe the functionalities of a software, such as what's going to be the business process, such as what is going to be the data manipulation, what is going to be the user interaction, okay, or how the data is going to be taken from the user and how that particular data is going to be used in order to like specify or in order to attempt certain applications. I'll give you two examples how we actually look at the development of the code. When you look at any specific code that is actually being developed, let's say that we have a topology over there, pretty simple topology like we have. So we have a router. I often take that this topology in our training as well, and there is kind of, you can say, a switch, and all of these routers are basically getting connected to that particular switch. And then this switch is connected to the management PC on which Python scripts and all are going to be developed. Now let's say that all these routers actually require of some deployment, maybe some OSPF deployment, maybe some BGP deployment or so. And there can be two things that can be done in this particular project, very small project, or you can say code. One, let's say a loopback needs to be created, and that particular loopback should be of the number of the router. Okay, so it should be, let's say, loopback 10 is actually being created, and that particular loopback 10 has an IP address of 10.1.1.1 with a subnet mask of /24. That is for our R1. What for R2 and what for R3? Similarly, let's say loopback 20 is being created and the IP address is 21.1.1/24, and 30 is being created, 31.1.1/24. Make sense? Now, how would you look forward to create this particular script? You basically would go over there and you can say import all the libraries that you want. And let's say we're doing that particular operation over NetMiko, which means using SSH, plain SSH as our transfer protocol. So we import NetMiko over there, and then what we're gonna do, we're gonna specify like R1 is whatever, R2 is whatever, R3 is whatever, and then you are going to get a connection like SSH connect is going to be attempted. After this SSH connect, you specify what commands needs to be deployed onto the device. So you say that we want to configure interface 10 whatever, and then you use kind of interface 20 for second router and 30 for third router. What did you do over here is you specified manual data in your script, which means you are going onto that particular script. You are specifying what's the username to log in into the SSH, what's your username, what's your password, and according to that, the configuration is being done. If you talk about the other way that you can do it, you can templatize this entire process. When you templatize it, what's going to be done? You're going to specify that loopback is equal to, you're going to use a function, pretty simple function input, and then you're going to say enter loopback number, right? So what's going to happen? Whatever value that the user is going to give, that value will be stored into the loopback variable. And when you want to deploy that particular config, you can simply say interface loopback, and then you can concatenate the variable loopback over there. So it will dynamically store all that particular value. And if you kind of put it in a for loop, then you can iterate that particular process for R1, R2, and R3. So these are kind of two ways of doing a particular operation. You can either manually specify things in your code, or you can use logics that are provided into the code for the betterment or optimization of things. So when, like, by taking this example, when you can say that when the functional requirements are basically taken in consideration, you should know that how user is going to interact with this particular piece of application, whether the values are going to be taken dynamically or whether they are going to be static. If they are going to be taken dynamically, how are they being stored, how security is basically taken into consideration and all. But most of the answers, or most of the requirement gathering that is done in terms of like ensuring the functional requirements and all, this is in the form of yes or no. Okay, and it can include words like you can do that, or you shall do that, or we should not do this particular thing in our code, or yes, we are definitely going to do this particular thing. Like you can build up certain questionnaires that would like give your answers in order to figure out whether the application is being built by taking or by thinking about the functional requirements or not, or by thinking about the maintainability or not. So, for example, some of the functional requirements, if we talk about, uh, you can say that whether web GUI, whatever application that you are developing, can user access the documents or can user access the details of certain things via web GUI or not? You can simply answer that yes or no, right? Or you can also say that can user uh, edit the details that he or she is going to feed into the documents or into the whatever details that the user is going to supply. So user can create or edit and delete documents. You can also answer that with yes or no. User can save documents on the local drive, yes or no. User can restore documents into to a previous version, yes or no. Right? Administrator can create and delete users, definitely yes or no. Documents can be sent via GUI to other devices, yes or no. All such kind of questions can definitely be answered in a yes no fashion. And on the other hand, when you actually look at non-functional requirements, then non-functional requirements tell you how system should perform those actions, which means you can also think of them as a quality attributes. So non-functional requirements often use words like they must do or they should do or so, and they are commonly measured over an interval of kind of a range. If we talk about non-functional requirements, let's say, uh, for example, you're creating this application, right? And in that application, the user is going to see a GUI, but that particular user needs to log in and then configure the network accordingly. So you can build up non-functional requirements in a way that the system uh, should support, or the user support that is actually going to be provided is for 10,000 users, which means an organization can create 10,000 users for this particular application. This particular thing is not a functional requirements. It's basically a non-functional requirement that actually specifies how the application is designed for how many people. It doesn't have anything to do with technically. And if you even talk about the other thing, like the system should be available at least 99% of time, so you can say SLA is equal to 99%, right? That's again non-functional requirement there. Or if we talk about the web GUI, the web GUI should take less than uh, GUI is equal to less than 1 second to load up, or rather, you can say less than a second to load. That's again a quality attribute, right? So, and you can even say that user are required to register before they can use the particular system, or passwords must not show anywhere in the logs or the GUI. The GUI system can be translated into all the other languages now. So when you talk about all these particular things, these are more often quality attributes that you want to ensure. But this does not specify the motive of what the application is going to do. When you specify the intent over here, that's where you specify what the application will allow you to do. Like user can access documents through a web GUI, so you need to create a GUI that actually allows the user to access the document, right? There are lots of technical I would say fulfillment that comes into the way when you say that user can create and delete and play with the applications. or play with the documents that are being stored there, or play with the code that are being stored there, which means you need to create some technical backend feature to this. But that particular feature will be available for 99% of time, or it will have an uptime of 99%, or almost 10,000 people can do that operation. That is not a functional requirement. This specifies the quality attributes. Okay, that's quite a difference between functional and non-functional requirements. So we generally take care of making sure uh, and checking what kind of functional and non-functional requirements are we gonna do. Okay, and you can also avoid using non-specific words when writing non-functional requirements. Like, instead of saying a request must be fast, you can specify an attribute along with it. When you say that GUI should load less in a second, okay, or it should not take more than a second to load, you are specifying what is your intent over here. You do not want that particular GUI to load in more than 1 second. But if you do not be specific, your answer to this also could have been that GUI should load faster. Now, what faster means according to you, and what faster might mean according to someone else, that can differ a lot. So you need to specify your intents over there. It's pretty much important. Okay, you might also see that the web page should load in 0.3 seconds. But if you say the web page should load faster, that doesn't clarify how faster do you want it to be. So you need to be very promptive when it comes to specifying your intents in terms of quality. Talking about whether to prioritize your functional requirements or your non-functional requirements is a question like, I would say, whether to prioritize one important thing or the other important, because both the things are pretty much important, right? One would argue that business is driven by the amount of money they earn, which can basically be directly correlated to their success in their business area. And in this case, business requirements that fall under the functional requirements are the clear winner, right? Because this is where the actual money is coming from. But if you are earning, for example, $10 a day by creating something that works for this particular operation, like, let's say you're automating or you're creating a project that actually automates deploying interface configurations onto the device. And let's say that the business is getting a revenue of $10 per day out of this particular thing. Now, you can say that business, or you can say, I should give more importance to this because that's directly driving money into the company or into the organization. But if you do not pay attention to the non-functional requirements, what actually specifies the quality attributes, then this $8 would slowly become $5 as well, because quality is not maintainable. Make sense? So you need to also give importance to the factors that not directly but indirectly draws money into the organization. Otherwise, whatever you're developing, that particular development might not survive for longer time. So, as with most things, it is important to evaluate requirements to see which ones should be prioritized and which one impact your application the most. The product owners may focus purely on functional requirement because they see money into that. But it may be up to the development team to take ownership of non-functional requirements as well. Okay, you might not want your management team to decide that what kind of SLA would be good for the application that they're developing. Okay, or what factor would be, how much of a time would be more than enough for the GUI to load faster and all. You should be the one, because you know the technical aspects of that particular things. You should be the one to design that, or you should be the one to take charge of that, not your management. Your management can tell you whether they want a GUI or not, because they know what their audience is expecting out of them. But you should know that how would it be the best in order to make sure that the GUI is available to the user. Okay, that's some sort of things that you also need to take care of. So to consider the impact of a requirement that has an application quality, or you can say assess the requirement by identifying the requirement and creating user stories. For example, users needs to have good experience while browsing. Now, you also need to determine the measurable criteria. that what would be a good experience. Okay, the good experience also involves the visual, right, the speed of the browsing, the elements that they see on the screen, the colors, the content, right, the features that are there into the user. And all of this particular task might be, you can say, developed or created by various other teams. Visuals might be taken care by the graphic designing team, speed might be taken care by the development team, element might be taken care by some design expert or architect, colors might be also taken care by the graphic guy, content might be taken care by the SEO or digital marketing guy, features might be taken again care by the business guy or something like that, right? All of the teams kind of involved into create one single application. Now, your intent is just to make the browsing experience best for your customer, but then you also need to be able to determine or measure what would be that best experience, what kind of visuals would be best, what kind of view speed would be best for your browser to load that particular page, what kind of elements should be there, what color coding, what content, and what features. All these measurable criteria also needs to be taken into consideration. And then finally you need to identify the impact. For example, user will not visit your site if it is too slow, right? So what can make it slow? You need to identify those particular things, and you need to get rid of that. That's pretty much the thing that you actually should be able to identify them. That's quite an overall, I would say, example of what functional requirement means and what non-functional requirement means. Make sense? Any questions? All right. So if you talk about the quality, or you can say non-functional requirements, and their qualities and all, there are some factors that we definitely consider. And when we basically consider, for example, let's say let's talk about functional requirements and the factors. So when we discuss about the functional requirements, they, as I told you, they are designed to be read by a general, not necessarily technical audience, but general audience. And therefore they're often derived from user stories. So user stories are short descriptions of functionality, as seen from the end user perspective and all. And they focus more on how the user interacts with the system, and what they expect the goal of the interaction to be, rather than what the system does. But since the software is often very domain specific, they help you to understand the system better as a developer. So another concept is used in formulation of functional requirements, which is basically use cases. You need to have very solid grasp understanding of what are going to be the use case for the development that you're going to do, be it product development, be it any web development, or be it something else. So in contrast to user stories, use cases focuses less on a user's interaction and more on the cause and effect of the actions. If a user story stated that a user can have or user can save documents by clicking on save, that's kind of a user, I would say, story, right? The related use case would state that when the save button is pressed, the current document is saved to the server's, no you can say, MySQL database, and to the client's local cache as well. So you understand the difference between user story and the difference between user, or you can say, use case. This user story definitely can be non-technical, and the use case definitely is going to be technical. So the general audience who is going to understand what your product does would more be concerned about um, how a user story, or what is the user story on that particular product. But when you're drawing a deal into the organization, or bringing in business, then your customer is going to be more concerned about the use case. not about the user story. They already know that the application is created that actually serves the purpose of your use, right? But what is the use case? How technically you are achieving that their requirement? That is what they would be more concerned about. Okay, so uh, the functional requirements, they also should be very, you can say, concise and to the point. Okay, they should be testable. The functional requirements definitely should be testable. They should clearly define who is allowed to perform certain actions onto the access data. Okay, for example, you're providing some outputs to the user into the application, but user can only do certain things over with that particular data. User cannot really modify the data of someone else's. Okay, there are multiple users there, they are storing their data onto the application. A user can only manage or change their data, not someone else's. Okay, but a developer definitely can. So you should be very concise about that. You should also fully cover every scenario, including what the system should not do and what a user should not do, so that you can save them from sticking into a wrong situation, right? And they should also include complete information about information going in or out of that particular system when they're using the application. The user should be aware about it. It's a different fact that user, like whether user goes through that information or not, but from your side, the information should always be available, so that the user cannot really claim that they didn't know about what is going to be wrong. So you should always have that information available there. And when you actually consider that business requirements are high level requirements from a business perspective, such as user being able to log in with credentials from an existing application. Right now, if you create, I would say, one Microsoft account, okay, or you can say Outlook account, then you can use the same account to log in into your Office 365. You can use the same account to log in into Microsoft Teams. You can use the same account to log in into, I think, Skype. You can use the same account in order to log in into the Outlook, definitely. So you don't need to create various other applications when the same entity is creating its products, and that can be a huge benefit to them. So user requirements contain the desired outcome of certain action, like the creation of a new document, right? Which will contain the name of the user, the address of the user, the contact number of the user, and various other information. And system requirements describe software and hardware specifications. So, like a specific error code being returned when an unauthorized code tries to access the document that is not theirs, right? That can be a specific thing there. And when you talk about certain things, these things should also be notified into that particular. So you think about what's going to happen when a user actually tries to do something wrong. They should be prompted with an error there. That's quite a pretty interesting thing that can be planned there. Whereas if you look at the same thing about how you maintain quality for non-functional requirement, non-functional requirement and application quality. So there are many different, I would say, non-functional requirement that exists, and the choice of which one to focus on can have major impact on like further development. And there are too many non-functional requirements that can make the development an incredibly long and complicated process. And there are too few non-functional requirements that can create an application that is what it is supposed to do. But it is very slow or insecure or costly to maintain. So non-functional requirements specify software product qualities or technical requirements of that particular system in order to make the user experience better. And there are many such things that can basically be considered. So I'll give you a list of certain, I would say, most used non-functional requirements, and some of them would also be asked into the exam as well. So when you look at list of non-functional requirement, then the very first thing that comes in my mind is availability. When you look at availability, the availability means that a degree to which the system is going to be operational, which means whether the system will be applicable, like accessible on weekdays, whether it will be accessible on weekends, whether it will be accessed on all days, okay, or whether it is going to be accessible all days, but with 95% of uptime, or whether it is going to be accessible with 99% of uptime or so. Okay. Also, on which platforms this particular application is going to be accessible on. Can a user use it on web? Can a user can use it in the form of an app? Can this particular app be installed into smartphone, tablet, okay, laptop, and whatever? Does it supports cross platform thing, which means same application can be used on iOS devices and same application can be used on Android devices or even the desktop platforms, the Mac OS and Windows and Linux and all these particular things can be thought of while ensuring availability. Then the second thing that you can talk about is backup. And backup is the ability to create a copy of data so that the system can be later restored from it. Okay, everyone takes something in consideration when using backup and all. Then the third thing that can also be thought of is compliance. Pretty important thing. So compliance is to make sure that you are not harming any organization's privacy or any organization's data breach or any other entity's data breach or so. Compliance is pretty damn important. And the fourth thing that you should ensure is data integrity. Data integrity is assurance of accuracy of the data that is being sent. For example, your device is connected in this particular fashion. R2 there, then you have R3, then you have R4, and R1 has a LAN, R4 has a LAN, and they both wants to communicate with each other. Now R1 is actually sending something called ABCD. So R1 is sending ABCD, and R2 or R4 is receiving XYZ. What does that mean? That means that someone in the middle captured the data, they did their hampering, and then they resend the data into the network so that the original destination can receive it. But it's true that the original destination received that particular information or packet or message, but the information was not what was sent from the source. So you use encryption algorithms and you use tunnels in order to make sure that the data that is traveling is pretty secure inside of that. That's something that you ensure. That is something that we call it as data integrity. Then you also take care of something called recovery, right? Data recovery also, and when you or disaster recovery also. So there can be physical as well as online attacks that can be performed. Some hacker can hack your data center and steal your data, or some physical thief can sneak into the data center and he or she can you can say steal your hard drive that actually consists data. So it's quite the same type of thing that's harming a single entity, which is data. Okay, and if anything happens bad to the data, then what's your plan? How are you looking forward to recover out of it? That is also something that needs to be paid attention. Okay, and then there are many other things. You have transparency, which is basically operating in a way that is easy to see for others. You can also think of security, that degree of resilience against the potential harm that can be caused by others. Responsiveness, portability, which is ability to port the system to a different hardware or software. while you're hosting it or so. That can also be taken into consideration. So these are a list of few non-functional requirements that are available. And then you have various other options as well, which is basically how you can increase the code quality. uh, for example, there are very well defined and implemented set of non-functional requirements. There are some great benefits if you talk about them, some of which is code quality, as I mentioned. So by taking into consideration, you can say that good coding practices and using standardized development practices as a non-functional requirement, that code becomes easier to understand and maintain. Because if I give an example, let's say that there is someone working on your organization, and that particular employee uses some kind of software development kit that has Python too. Okay, then it has Eclipse as its IDE to develop the thing, and then it uses certain other coding standards to modify the script and all. Now let's say that there is this particular guy left the company, and then in replace to that, the company kind of hired someone else, but that particular person uh, also uses SDK, but he knows Java better, and then he uses some Java development application, maybe VS Code, right? Or Python 3, but not Python 2. So that kind of clashes the thing, right? Just because the user is specifying that I'm going to use Eclipse, the organization might purchase a license for that. And the organization definitely would want that when she's done, when you can say he or she is done developing the product, and when they leaves, that particular I would say thing can be continued in order to develop the thing. But when the employee leaves, and when there is someone else who is kind of coming up in order to develop the continued thing, the user or the developer gets to know that these are not the softwares that I use in order to develop an application or so. So that kind of harms the development. That's why it's pretty important to keep the thing in standard, and make sure that everyone who comes on board on the project uses the same resources for developing or creating the script and all. So that's also something that can be that can be given importance. Then, if you talk about some other methods, then better speed and performance, as we talked about, that's there. You should ensure that there are very fewer bugs into the application. You should also ensure that there is higher uptime, improved security, better user experience, and all. All of these factors adds value to your product, and there can be some harms as well. If you look at the harms, or if you look at the possible or potential mistakes that can be done to an application, is lack of testing. Okay, the code tests are often skipped since they are usually not part of the requirements. So this particular is higher number of this particular causes a higher number of bugs that get past the manual testing, and they are discovered later when an application is already operational or already is in production. And you can also think about weak security as one of the reasons. Okay, so high security is often a big a constraint onto the system. For example, using proxies, access list, and encryption and other things. Or you can say security often is less strict during the development phase or so. So that can cause harm to the application. So these are functional and non-functional requirements that are taken into consideration when you actually talk about maintaining the things. And then if you talk about how these particular things can be maintained through that, then there are additional steps that are also taken into consideration. So we definitely would be talking about that, but there are two ways that you can maintain or that you can save your application from. One is like maintaining through design perspective and maintaining through implementation perspective. So let's see how that particular thing goes up. Now, talking about maintainability and a couple of ways that we can do it. If we think about maintainability through design, then if there is one thing that you can be sure of when designing your application, it is that you will have a chance, you can say you'll have to change something at particular point. While most changes can be done with enough time in your hands, but this will often not be the case, because by designing your application to be maintainable, you can save a lot of time and trouble in the future. So in the recent times, there are software projects uh, that have kind of grown considerably in both size and complexity. And there are project life cycles. You might have seen them into the self-study sections of your DevNet associate course, that how lean, waterfall, and agile, these are the software development models that are taken into consideration as life cycle parts, okay? Or you can say software development life cycles, SDLC models, we call them as. So these project life cycle also taken into consideration, that actually costs often, that actually requires you to specify like monetary budget to. When you use a project life cycle that can basically dedicate more than 75% of the resources on to maintaining and modifying the existing project to fix errors and add new functionalities to meet customers' need. And even if the requirements were gathered and followed, you can say, then it is not uncommon to miss some of the use cases and some of the requirements that can be additional, that can add additional functionality to the application. So change is something that is not avoidable into whatever you're going to develop. Okay, and you need to maintain and improve the software or application as fast and as cheap in you can say monetary that you can. So maintenance cost includes certain things, which actually lists about fixing bugs, then and errors as well. Apart from that, you can also call adding new features, right? That can be another um, motive towards creating budget for adding new features to it. Then the third one can be, I would say, performance optimization, which means you have your application developed, but you can create a better version of that particular thing. And when you create a better version of that particular thing, that can actually optimize the cost, or that can actually optimize the behavior of performance of that application. So applications usually have room for performance improvement. You can say runtime analysis can highlight performance bottlenecks that can be optimized so that the application can perform better also. And these bottlenecks can be correlated. So you can also take that particular thing to environment as well. Like if your application is actually hosted in a data center that has bad network or that has bad resources, then that bad network or bad resource can also cause the performance to be degraded for the application that you're developing. So there are certain things that you can take care of. So one of the principle that is followed in order to work on maintainability through design is called as solid principle. And the solid principle includes certain elements. So the solid is not actually a name, it is an acronym that a software design principle is used for. So the S of solid stands for single responsibility principle. So there is one class that should have only a single responsibility, right? Which means in your code and all. And when you talk about this thing, then there, like when you create your Python code, that particular Python code can have multiple classes or multiple functions that are there. But if you gather all of those particular functions in one class, then that can actually create value to your code. And apart from that, there is second, or there is O. That acronym, the acronym for O is open close principle. This open close principle is nothing but components. So there are components which can be classes and methods and functions and all. They should be open for extension, but they should be closed for modification. What does this particular thing mean? Is if you have a function that is created, that particular function can be used by inheritance. Okay, from like in the same script, you are defining one function above, and then you are reusing that particular function somewhere down in your code and so, which basically comes under open close principle. I know, like we might have been familiar with, and we might have been using these features as well of various coding languages, but they comes under certain key aspects or key principles. So that's what is like listed into your solid principle or so. Now, when you talk about the third one, which is basically stands for L, it's called as Liskov's substitution principle. Liskov's substitution principle. This is derived with the types that must be completely substitutable for their base types. I'll tell you an example about what this particular thing means. And when you talk about the fourth one, which is I, it stands for interface segregation principle, which means clients should not be faced, or clients should not be forced to depend upon the interfaces they do not use. Okay, so there can be a GUI that is developed, and that particular GUI has lists of interfaces, or you can say lists of tabs. You might have a home tab there, you might have services tab there, you might have various other tabs that are available there. And they should not really be depending upon the interface that they're interacting with. You should also give options that if someone doesn't feel comfortable using the GUI, you should also have the option to let the user do modifications by using CLI. Or you should also have an option to let the user do modification by using code. That code definitely can be built up with API calls. But yeah, all such kind of options should be there. So that's something you can call as interface segregation. And then the last one, which is called as D, stands for dependency uh, inversion principle. Yeah, dependency inversion principle. This dependency inversion principle means that you should add a program to an interface, not to the implementation there. Which means you can say, so these are quite five principles that are subset of many software design principles that actually apply to object oriented design also, and they translate well to general software development. And they can you can say they have become very popular when applied in combination with the agile development. And as you basically would experience something that when agile software development lifecycle process or agile development method is used in combination by adhering the solid principles, then it makes it easy for developers to maintain and extend the software. They also reduce the amount of potential technical debt and they keep the code flexible no matter how the functionalities are added on top of that particular thing. So there is, let's say, if we take an example of there is a Python class that has not one but there are multiple responsibilities there. So for example, let's say we create a class there. We say class is network service, and in this particular class we definitely have a default function. So I say default init, and in that I specify a self parameter, and then I have name, and then I have config. These are my parameters, and I say self dot name, okay, is equal to name, and self dot config is equal to config. And you can definitely pass values afterwards into this name and config as attributes and so, right? Apart from that, there is another function. So I say define uh, set name. In this set name, we have self as a common function, and then we have name. So I say self dot name is equal to name. Once we have that, then I said define. I'm just creating a function there. Set config. And I say self comma config, and self dot config is equal to config. Sorry. Now when I say define deploy underscore service of self, what I'm going to do is I'm just going to specify the another function, or call another function right over here, which I'm going to use as infra dot deploy, and in bracket I'm going to call self dot name comma self dot config. There. So let's talk about what's happening over here. We have a class over here, and if, like, it is said to be pretty honest that if the class handles more than one responsibility, then any potential changes that affects others, or that affect that particular function, is going to affect the other functions too. And this is not ideal when handling small applications, but it can become a complete, I would say, nightmare when you work with larger enterprise systems to have classes that are used by like several unrelated subsystems. For example, a class that actually handles creation of weekly financial reports, and that contains some methods that are used for formatting data within the accounting and HR departments. Now these are two different things that are being done, right? You can say formatting that particular creation of that data, and then also handling some other tasks of some other department. So the principle should be applied not only to a class level, but also to on an entire module. And or if even if like there are methods that are being used or microservices that are being used, they should also be applied with the same principle. So a common beginner's mistake is a method that is too long, and you can say does multiple things, such as a code that actually makes a get request from a resource, like let's say fetching out interface data from your networking devices, and then it parses the response and it saves something to the database. And all of these three like things, like getting the response, parsing it to or passing it to some other data structuring language, and then it's saving it to a third party database, and all of these particular requests are into similar function there. That's quite kind of say irrelevant thing that should be done. So there is a class that we have over here which is called as network service, and this particular class violates single responsibility principle because the class network service has two responsibilities into this. Okay, first, it takes care of setting the class parameters, which means we are basically setting up like self.name is equal to name and self.config is equal to config. So we have two functions over here, set name and set config. And when we are like going to specify these particular details into the function, that's one function. Okay, so it's basically it takes care of setting the class parameter, which is set name and set config. In addition to it's deploying the service itself as well with the in the deploy service, I would say function. So this is responsibility number one, and there is responsibility number two. It can also be, I would say, like how you can improve that, because the network service that is actually being used to apply a single responsibility principle, you need to decouple the responsibilities. And how can you decouple the responsibilities? You simply need to just create another class, maybe over here, and you say class network service deploy. Okay, and in that particular class you specify whatever function is actually being used. Okay, so you can call that set name and set config inside the bracket over here, and that will basically solve the purpose. So it's not like this particular, like the previous script that we worked with or the previous thing that I mentioned there is not going to solve the problem. It's definitely going to work out, but it's not the optimum way of doing it. So you can say for this example, the network service class should only be responsible for setting the data for the services, and then the second particular class should be able to deploy that. So in practical terms, this allows two developers to work on these particular classes, and one can change how the service parameters are set, while the other one can change how the service is deployed, and all without affecting each other's work. That can be a collaborative effort. So such kind of things doesn't seem too important, but they definitely add value to your development or to your deployment that you're doing. So that's something that you can say. That's how designing of things needs to be taken in consideration. And as soon as you start adding more, you can say features inside your or more responsibilities into your code, you start creating more classes so that they can be used in a network wide fashion. That's one thing we treat it as maintainability through design. You need to see how your code is actually designed. Is it proper or not? And then the second thing comes up, which is called as maintainability through implementation. So while design plays or when you say while designing and all plays a big role or plays a big part in how maintainable your application is, the implementation itself can amplify or diminish any benefits to maintainability. So adhering to the industry's good practices makes implementation and later maintenance stages much more smoother. For example, during the implementation phases, there are major discussions or major decisions that should have been made, but it can be revisited as well. Or consistency and coordination with the team are pretty important. Or stick to common tools and languages and techniques also are pretty important. So you can say to understand how to build maintainable software or maintainable code or maintainable application during implementation, first it is important to understand the implementation phase. So when you talk about implementation, then the focus shifts, or you can say this is a phase where the actual application gets built. So the focus shifts from software designers and architects to developers who might be the same people as well. But the developer begins developing the code and tests it, and the designer helps with graphical materials, while the system administrators build the environment. And there are like other people who are responsible, as I told in the earlier section as well. So while depending on the development model, if you consider agile, okay, or if you consider lean, or if you consider waterfall, most of the major decisions should have been made earlier as well. It's not like uncommon to see design modifications due to unforeseen consequences, but ideally this should be kept to a minimum, because in all the software development life cycle, be it agile, lean, waterfall, and all, there is the very first stage which is called as information gathering. In this information gathering, everything should be discussed prior to deploying a configuration. If you even have seen a web development project, what you might see is, first there is a requirement gathering. Second, they basically propose the intent. Okay, by discussing with the team, the you can say serving company will create a proposal for the client. So client can either agree to it, or deny to it, or propose further modifications. Once the proposal has been accepted, then the graphic team basically creates a graphical view about what the user is going to, or sorry, what the customer is going to receive. Once that particular thing is approved graphically, then the code actually is developed. Okay, and then further testing is done, and then the thing goes into maintenance, right? Or maintenance, you can say, or deployment is done in continuity. So that's where CI/CD pipeline and all comes up, which we're going to talk about it into further things. But yeah, if this graphic and purpose intent, or you can say requirement gathering phase, is not executed with that depth, the people definitely are going to face issue when the final code is done and the testing is done, and then you propose that, or you produce that particular development to the client. Then client might say that this is not something that we talked about. So it's pretty important over there, and most of the major decisions should be made in the early phases only. So the implementation phase commonly includes many developers. If every developer uses that particular favorite tools, or languages, or libraries, or coding techniques, or even versioning, then the project soon becomes an unsightly mess, because the no one would want to, or you can say, whenever some developer is using some product or some SDK to deploy one thing, and the on the same team someone else is using some other type of libraries or so. Okay, for example, I want an application that actually exports data to a third party file. Let's say I want it to be done in CSV. Whatever Python output is created after executing that thing, that output needs to be exported to a CSV file. So a developer is creating a code to do that by using import CSV. Okay, and some other developer is basically doing it by saying import pandas. Now these are two different libraries that they're using, which actually solves the same purpose, but this is definitely not expected to be followed into the production environment, right? So this increases the bus factor onto that particular project, and the bus factor is nothing but a measurement of how much a project will suffer if the project member suddenly becomes unavailable, right? Because the member has been creating a code by using CSV, but the other onboarded guy who is going to take care of that particular thing uses pandas in order to deploy the same thing. That creates lots of unnecessary, I would say, delay. So using common implementation techniques allows many developers to work in sync on the same project, no matter like the actual functionality. And You can say it lowers the learning curve as well. When developers work on the code, they did not write themselves. So good implementation also reduces the number of errors, and it can lower the implementation and maintenance time considerably. Okay, that's something that you also need to take care of. And then using functions and all these other things, versioning and every other thing is definitely basically considered over there. So that's going to I would say make a lot of I would say effort, or make a lot of difference when you talk about deploying certain application or so. That's one thing that is there. And these are two methods of how I would say maintainability can be done. One can be taken care of by doing design, and the other one can be taken care by doing implementation, and like the thought process behind that. Questions? More of a theory and theory thing, but yeah, the course has a lots and lots of theory that needs to be covered there, so bear with me for that. Now, talking about the next section, which is I would say designing for serviceability. When we consider that, we specify that when we talk about designing for serviceability, then it's more about not maintenance, it's about how service can be done for an application or so. So when you look at a serviceability thing, or when you look at an application, then in that particular scale, or in that particular thing, software departments um, like write computer softwares. However, when an application is deployed in production, then there is a DevOps team, right? Or DevOps or operation departments uncommonly or commonly share the take over servicing or monitoring or supporting it. So for this particular reasons, applications should be serviceable, and by any person who has that particular knowledge of how servicing can be done with enough training, and not just like the application developers, but any of the DevOps team as well, or DevOps member as well. So application serviceability is a trait that tells you how easily an application is to install or configure or monitor. Okay, and it makes sure that it provides the service it was intended to in the easiest way possible. So as with maintainability, the serviceability must be considered as well in the design phase, since later changes can be very costly and it can be very difficult to implement. So maintainability and serviceability needs to be pre-thought while the coding starts, but they definitely are going to benefit you post the development. They're not going to benefit you for the development also, but once the product is ready, then the team would not have to much then the team would not have to spend much and much of time to maintain it or to service it. So that's why this things needs to be pre-thought. So software applications, when we talk about that, then there is something, I would say, a stage which is called as observe the app design. Okay, observing the application design. So software applications are becoming plentiful and more complex every day, and applications are no longer built from one or two services and installed on a single machine. Because if you've gone through a section into your associate course, there is a section that is called as application deployment, right? In that, you might have seen various methods called bare metal deployment, where there is only one single server that is used, and then a single application can be hosted. Then there comes the VM based solutions, which means you can create different virtual machines and install on the same, I would say, server, while every virtual machine can host a different application. So that basically gives you the ability to host multiple applications on a single server. Then there came the cloud native applications, where the containers and microservices and all were introduced and all. So there are multiple ways about how a software can be deployed. And when you talk about them, then the applications are no longer built from one or two services. And this change, when you look at that, from bare metal to cloud native applications to microservices to containers and dockers and all these things, the change is great for applications and the user as well, but it complicates the application's serviceability, because increased complexity is one of the reasons why the observing is becoming very important in the applications. You need to observe. We were talking about observing the application design, and when you look at observing that particular thing, there are certain questions like when observing an application for its operational states and all, there are three questions that you can ask to the application. One, it's like, what is the application doing? Right? Like the application itself can usually tell you the most about what it's doing, since it knows the operational context. So the process where an application notifies the observer about events, actions, and errors that are happened during the runtime is called something as logging, right? We recognize it as logging. And it must be designed to clearly convey relevant information to the observer. So let's pick a router over there, and then that particular router, we go into the interface FA0/0, then we say no shutdown. Once we do this no shutdown, we see a log there coming up that indicates whether the interface is okay or not. If we go into the device and we again say IP address DHCP, after we configure IP address DHCP on the interface, you again get a log that there is a certain IP address that has been configured onto the device, and you get to know about something has happened. That's one proper example about what logging is, right? So your application also should be developed in keeping in mind that logs and all should be produced to the user. After that, the second question that can also be taken care of is, what are uh, the supporting systems doing? Now, when we understand what are supporting system doing, supporting system, which includes the hardware on which the application is running, and the internals and external systems operations that actually enable the operation of the application. So it can tell you a lot about applications operation. The application can run exactly as designed, but if it does not have enough memory to process everything in time, or if the database queries takes too long, okay, or if the RAM is not there, if the CPU is not there, the enough resources are not available, then the application definitely is going to underperform, and it can become unstable as well. So monitoring is a popular technique. Uh, Monitoring, yep, monitoring is a popular technique to observe the supporting systems for operational parameters and all. Okay, and the third one, which is called as, what are the users doing? That's the third question. So the users can sometimes surprise developers the most with their innovative ways to use applications, because there are hundreds and thousands of users that are going to use your application, and someone or some other every other person might have different approach or idea to use the application that you are creating, right? And that might surprise you sometimes that some user ended up doing some weird thing that nobody could have expected, right? Even though some applications do not have any active users, and they are automated processes that actually derive these particular things, but um, if they are doing what they are supposed to, the documentation is kind of a great way to let users know how the application that you have deployed needs to be used. So there is, you can say, comes documentation. And documentation is an answer to always let your users know how they should use your application. Consider some of the examples, like status of the application components, or health checks on external systems, or you can say operational status of services, or user triggered actions, or hardware status to loads and all. All of these particular elements can definitely be pretty helpful when they are used into creating a dashboard that might help user to know about an application or so. Makes sense. That's something how you can work with. So logging, monitoring, and documentation, these helps a lot into when an application is deployed. So these are some of the things that we kind of discuss about that actually makes the application scalable, that actually makes the application maintainable, and that makes it observable.